This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make wind turbine lightning protection easy. If you're a wind farm operator, stop settling for damaged turbine blades and constant downtime. Get your uptime back with our Strike Tape lightning protection system. Learn more in today's show notes or visit weatherguardwind.com/striketape.
Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. Welcome back to the Uptime Podcast. I'm your co-host, Dan Blewett. No Alan Hall on the show today, but we've got a great guest. Lasse Hieteko from WEISTech is here, and he's going to talk to us about blade heating technology. So obviously, we were looking for someone for the show to talk about, some of the issues that happened in Texas, right? Obviously, terrible disaster with, all forms of electrical energy or of electricity going out in Texas. Obviously, wind turbines were a part of the problem, right? They iced. They had winterization issues, they froze, and they lost power. So we want to have someone come in who actually has a solution to this. So Lasse is the business development manager for WEISTech, and WEISTech is a Helsinki, Finland-based company. And what they do is they have blade heating technology. So it's essentially a carbon fiber mat that they lay on the leading edge that has, resistive heating, similar to what's in, the rear view windshield of your car, where they'll kick on when temperatures, when, the sensors on the turbine say, hey, this is a icing condition, those will kick on and they'll prevent ice from forming on the basically 2/3 of the blade, the most important aerodynamic region. So not the root, but the outer 2/3, almost all the way up to the very tip. So it's really interesting, the fact that this is, it's been out there. This is not new technology, and he speaks to that this is something developed in the 90s, and they have the IP of this at WEISTech, but it just isn't always deployed in all these new sites. So a lot of it's done in the factory. They do a lot of installations in the factory, and they're just now getting into retrofits, which is obviously going to be of significant interest now that we've had this Texas disaster. We've seen the damage it can do if winterization is a problem, and you get one of these sort of black swan event kind of winter storms. So Lasse has he's a master's in mechanical engineering from what is now Aalto University in Finland, and he's an expert on this technology, on blade heating, on the economics of it, and whether it's going to make sense for either a new wind site in development, because this probably does need to be part of the discussion going forward, right? Hey, are we going to have icing issues? And also companies that are having wind turbine issues with icing, with winterization, they're getting more and more calls daily now because of obviously people don't want this to happen on their site. So we're really excited to have Lasse here. So without further ado, we're going to jump into our conversation with Lasse Hieteko from WEISTech in Finland. So Lasse, thank you so much for joining us on the podcast. Really appreciate it. Good to have you.
Thank you very much for inviting. It's really nice to be in here.
Yeah, so obviously there was a really big incident in Texas here in the U.S. And so we're, looking of, who are the experts in this field, and, with wind turbine blade icing and de-icing and trying to keep them winterized and keeping them running. I think that's it's a pretty pertinent topic right now here at early 2021. So we'll get to the Texas thing a little bit more as we go. But first, as a member of WEISTech, can you talk a little bit about, why do wind turbines sometimes stop running in the winter? What are some of the issues, and why does that happen? Why do they stand still?
The turbine blades are, of course, when the weather gets cold, the blades get cold, and they are hitting the moisture or small water particles that are on the air or on the clouds, and therefore ice starts to accumulate on the blade surface. Or the ice on the blade then destroys the aerodynamics of the blade, and therefore it's not that wind turbine is not producing any more power. So it doesn't need to be a lot of ice there that it starts to bring the power down.
So we've had an aerodynamics expert, Nicholas Galdern from Power Curve, on the show, and he talked about how, turbine blade erosion and accumulation of dust and dirt, even just a little bit, can, like you said, ruin the aerodynamics, and they can hit their stall point, and now they just won't turn. So it sounds like that's pretty easy that same problem happens with just even a little ice accumulation. Is that right?
Yeah, it doesn't need a lot when you already have like minus 50% or even minus 70%. So it doesn't need much ice.
Yeah, and I think that's the really confusing thing for the public here in the U.S., where they think about these wind turbines like, why would they stand still? Like, ice isn't that heavy. But it's the same thing with an airplane, right? Like, you have to de-ice airplane wings because they're just not going to fly at all without it. It's just the aerodynamics are shot.
Yeah, because if there's even a little bit ice on the blades or on airplanes, it's the same thing, that aerodynamics is not working anymore. So well, we have had like pictures of wind turbines that have a lot of ice, but we have lately decided try to like avoid of using these pictures where there's massive load of ice, because the small amount does the same.
Yeah.
There's not needed.
Yeah, I've seen some of those pictures where they're just like just tons of it built up, and you're like, yeah, I guess that makes sense. But it's, like you said, just a little bit is all that's really needed, and especially out towards the tips. So can you talk a little bit about the root versus the tips of the blade? I mean, is there a difference in, does it matter if there's ice near the root, or does it matter most towards the tip of the blade?
Typically in our design, we have the blade heaters in roughly 2/3 of a blade length, and not at all on the root part of the blade, as the aerodynamical critical areas are the first 2/3 of the blade.
Okay, so you're not really focusing too much on the root.
Aerodynamical point of view, it doesn't matter if there's some ice on the root part. Gotcha.
I want to hear how your solution works to keep ice off these blades. But before we get there, how does the turbine have anything to know when there's ice accumulated? Is it just a visual thing, or is it just like it stops because of the aerodynamics, or is there some other way? Are there sensors? I mean, how does that work?
Well, many turbines are sensing from the power curve, like you said. Or there are many kind of sensors on different types of turbines. They might sense vibration. There are many types of sensors in turbines, and when they like start to think that there might be ice on the blades, and then many of the turbines just stop themselves like automatically.
Gotcha. They just know when to shut it off. Okay. So tell me about WISE-TEC. Yeah. So your WIP system, WIPS, what does that do? How does it work? Where do you install it? What's the process like? Can you kind of walk us through it a little bit?
Well, our technology is invented already on 90s. So it's not something really new. So it has been there for over 20 years already. And it was originally invented on a Finnish National Research Institute. But nowadays, our company WISE-TEC owns the IPR for the technology and is further developing it today. So this technology has been installed to many different types of turbines, on new ones, and lately also as a retrofit to the existing turbines. Yeah, and the technology is carbon fiber mat on leading edge of a wind turbine blade, and it works as a like resistive load, so it heats up when we connect electricity to this carbon fiber.
Okay, so you take the carbon fiber mat and you've got to lay it all along the leading edge of the blade, and I assume you have like a resin system or something that you epoxy it down, and then so it sounds like it works kind of like the the little screen that they put on windshields, like rear windshields in cars to defrost. Is that sort of is that a decent analogy?
Yeah. So it heats up pretty quickly, and when the carbon fiber it's really close to the surface of the blade, so it brings the heat quickly and efficiently, just where it is needed, and even if it's only on the leading edge, it also keeps the trailing edge pretty much clean of the ice.
How is it? Why does it do that?
It heats up a little bit the air that is flowing
Gotcha.
along the surface of the blade, and it is also a matter of design and calculations, so that the size is correct, so that it needs to be right size for the blade, so that it keeps the trailing edge as well free of ice.
Gotcha. And so it doesn't sound like this is like a de-icing solution as much as it is this is just gonna keep ice from ever accumulating. Is that right?
Yeah, we call our system anti-icing system. So we get a signal from ice detector. Typically we use a Labcotec ice detector, and when the icing conditions are starting, then the heating is switched on, and
Gotcha.
that happens totally automatically. And the control software takes care of the heating and the overall process, so that the heating is on as long as needed, and then it turns off automatically when it's not anymore needed.
Gotcha.
And so that the heat before the icing starts, or before the ice starts to accumulate on the blade surface.
Okay. So it sounds like that could be used in a situation like Texas was a good example, where it's not really that cold most of the year, and maybe it's not going to need to be on and waste electricity powering the whip system, but if it does drop cold enough, then it will kick on and keep the blade free from ice. Is that right?
Yeah, and this technology prevents like the massive amount of wind turbines shutting down at the same time, as the blades are staying free of ice, or at least a minimal amount of ice, but they still stay operational.
Gotcha.
So when there is bigger amounts of renewable energy and wind power on grid, so it becomes more important to keep your turbines operating even in icing conditions.
Yeah, so I know we're going to get a little more to the economics of it and back to the Texas thing in a little bit. I still want to hear a little more about the installation, all that stuff. So you said most of your installations now are done in the factory. And I know you're, like many companies, you've got NDAs, so you can't disclose lots of details about companies you work with and all that stuff, which is totally fine. But you do a lot of it in the factory. But you're now starting to move into retrofits. Is that right? So can you tell us a little bit about it? Sounds like the process is a little bit labor intensive, but you're starting to figure out the retrofit situation and are trying to streamline that process. Is that right?
Yes, we did 2016 first retrofit installations at the site Lac Alfred in Quebec, Canada. Since that, we have done total of 28 retrofit installations to the same site, and this summer we are doing 14 new retrofits to Quebec, Canada, but to a different site.
Gotcha.
So until now we have brought the blades down and transported to the temporary factory where this heating element has been installed to the blade surface. But we are at the moment developing our technology so that we are able to make this installation up tower, so that the blades will not need to be lowered down anymore.
Mm-hmm.
Yeah, it's a cost saving, and it's also a matter of crane works. There's sometimes can be tricky to get the cranes on the site, and needs possibly permissions for cranes, and so
Yeah.
we are really looking forward this up tower development. It will be enable for get this technology to many different sites in the future.
Yeah, because I imagine the really cold sites that you probably can't do work on them until, you know, it warms up in the summer, right? And then when that starts to happen, I assume there's tons of moisture on the ground. The ground's really soft, so that probably makes getting a crane up there pretty difficult.
Yeah, many sites that are our customers, there is a long winter, and so when the snow is melting away, so ground stays pretty wet for a long time.
Mm-hmm. So as far as, you know, like you mentioned the Lac Alfred wind farm, I mean, you said they're one of the probably the roughest wind farms in the world as far as ice conditions and snow and all that stuff. And there's a lot of wind turbines running in really rough environments. What was unique about Lac Alfred? Why did they decide they needed help?
Well, they are up in the mountains, the site, and there is a proximity of Atlantic Ocean, so there's continuously moisture is rising out the ocean, and then the wind is blowing up to the mountains and bring the moisture there, and with moisture together with the cold weather, it just like brings the ice to the wind turbine blades.
Gotcha.
And there's like the winter time production losses are pretty big on that side, and we are happy to help our customer on their production.
So do you feel like are there a lot of sites like that one that maybe didn't install blade heaters from, you know, the factory, that, you know, it seems like maybe that environment would have been a good indication for it? Because I mean, that seems like a really, you know, like you said, a really rough environment. For me, I'm thinking of like Chicago here in the US. Chicago is, you know, it's got the, you know, Lake Michigan right there. So there's tons of moisture in the air. There's tons of like sideways rain and sideways snow. And as I know, they're going to start putting wind turbines in some of the Great Lakes here in the US. And so for me thinking, oh yeah, that seems like that same kind of environment, very cold, very windy, very wet. Are you seeing more and more customers saying, yeah, like this seems like a need, we should definitely install heaters on these blades from the beginning?
Yeah, we see definitely like increased number of inquiries for the technology, and well, the Quebec area is really prone to icing. It's not just Lac Alfred on the area. There's several sites around the Quebec, and the like northeast USA, like New Hampshire, Vermont, Maine, and New York, state of New York. There are sites where icing is seem to be quite big issue, and in general, the higher you go up to the mountains, the more issues you typically have.
Plus, that's going to make it really tough for them to, you know, if they're all the way up in the mountains, they want to probably keep them running. Obviously, well, they're always going to want to keep them running, but they want to keep them running as much as they can with as little downtime as they can. So you think really planning ahead and saying, hey, in the planning process, what are the what things could, you know, cause these to stand still? Like, for example, like we talked about earlier, if you're in India where there might be tons of dust and dirt, you know, they might need some solution to clean, you know, the blades more often, and they need to probably plan and budget for that. So I'd imagine that this would probably be a big budgetary concern early where, hey, if we're going to put them up in this area, like a de-icing system, preventative icing system's got to be in the works in that budget. So that seems like a no-brainer from an economic standpoint. Okay, so if I owned a wind turbine site now, and I'm now worried because of the Texas incident with the huge power outages and all that stuff, how would I know if I need this, right? Is this something that, like I know Texas has pretty fair weather, right? They don't get a ton of really cold storms like they did. This one was an anomaly. So as an owner, you might say, do I need, the cost of this retrofit? Or do I need the cost of this out of the factory? Or am I only going to get a potential ice situation once every 20 years where it's just not going to make economic sense? How do you advise companies as far as when they probably need this and when they don't? And if they're having problems, what does that conversation typically look like?
If it's a new site, then of course during the development phase, you should have your ice assessment done.
Mm-hmm.
But if it's a existing site, then we typically first ask that, okay, what is your loss? What is the number of how much are you losing? And some sites know they have good idea of the icing losses, but some sites do not know what is their yearly icing loss. So of course, first thing is to analyze your how much you are losing, and what comes to the icing, it's there's much more bigger variation than in for example in the yearly winds. The wind variation is much more smaller than variation in icing. Or always there is the business case in some point where you need to consider doing something for your issue.
Is there is there a rule of thumb? Like, is it a couple percentage points AEP? Is it 1, 2, 3, 4, 5%? What does it typically look like where they say, hey, it looks like we're losing X amount where we think we maybe need this?
For new sites, it's 2 to 3% from AEP when you should consider blade heating.
Gotcha.
For existing sites, it is more expensive to do as a retrofit, and then you can't direct say what is the percentage. There's so many different factors that are affecting. But of course, if you start to go over 5%, then I think it starts to be good to figure out how you can solve it. It starts to be a lot of money.
Well, so I've heard some, depending on the municipality or the part of the world, that some companies just seem to overlook. They just seem to overlook the icing issue. Like they just sort of, maybe they have power generation from nuclear, they have a little bit from hydro, and then maybe they have some wind power. And maybe they're like, we have icing issues and our turbines, they stand still, for like a month every year, but it's not a big deal. When they turn off, we just kind of divert and we get more power from nuclear. Do many site owners have that attitude where, they just see it as like a thing that happens and they're not overly concerned about it? But I mean, it seems like from my perspective, they should want to have no downtime whatsoever. It doesn't matter what the conditions are. I mean, where do you stand on that?
Yeah, well, from the grid point of view, there's like you said, we have heard this kind of stories that it doesn't matter if the turbines are iced up, as can always use some other source available. But what from the point of owner point of view, of course, like any owner, should be interested how much they are earning, and during the winter time the prices are high, and the air density is higher, so you get like double production in winter time compared to the summer. So it's really valuable time to make money. So you shouldn't, like as a wind farm owner, you shouldn't lose your like valuable time of production during the winter time.
Okay, so you get a surge in production anyway because
yeah.
of the air density, you're saying?
Typically in cold areas, the winds are higher and the air density is higher, so that leads to a higher production.
Gotcha. And let's talk about the size of turbines. So obviously, they keep getting bigger every year. Where we've had other guests on from different companies where they're saying, yeah, the fire suppression systems from Firetrace were a good example. Where it's like, yeah, for a 2 megawatt wind turbine 5 years ago, maybe the cost was a higher percentage to get all these different add-ons installed. But now, when you're talking about a 10, 12, 15 megawatt turbine, that these are, $15 million machines, it doesn't even make sense to not install some of the things that are going to keep them running because they generate so much power and they're so expensive. So do you see the heated blade technology being more often adopted now that these things are so big and they just do not want them to stop?
Well, at least here in Finland, I see that there's many projects that will be installed with this surface-based heater, and the potential loss is just so big with the new big turbines that they are not. Or I heard that from one developer that they just were like afraid they couldn't take the risk or to leave it out.
Yeah.
And when the big turbines are more expensive, the relatively like cost of blade heating is smaller. Also, when the turbines are bigger and they go more often sweep higher and for example in the clouds, so then it also leads to the situation when these turbines are more prone for icing, because our blade tip more often hits to the clouds when they reach higher. And
that's really interesting. I never thought about that, but
to icing.
But so the shorter turbines are kind of staying in slightly warmer air where there's, obviously, like you said, not reaching into the clouds. But when they get to a certain size, that tip is reaching through colder air and sweeping through clouds where there's more moisture. And it's almost like it's able to reach up and grab and find icing conditions. That's really interesting to think about.
Yeah, for example, on the same side, if you're rip off your old small turbine and replace with a big modern turbine. Well, the old small one maybe did not have any icing issues, but the big one might have, as it goes so much higher.
Yeah. Huh.
And
yeah, that's interesting. So then, and there's another competing. So the surface heating technology that you use is not the only potential solution for icing. What's the main other competing technology? It's forced air, right? And how does that work? And does it have the same effect?
Yeah, there's this like hot air blowers that typically blow hot air inside the blade, and many turbine manufacturers have this kind of a solution, or have had at least earlier available. But now when the turbines are getting bigger, the blades are getting longer, the hot air is not just efficient enough anymore, because the air volume is getting so big inside the blade. And also in many areas where it's extremely cold, the hot air just is not efficient enough to keep the turbine, like the blades, free of ice.
Yeah, plus I mean, the materials of a modern blade is made out of, with carbon fiber spar and just like the thickness, and I mean, they're so big and made of fiberglass. It seemed like that would take
Mm,
some really hot air and a lot of it to heat something that's that thick and
yeah.
it's made of a non-conductive material. I mean, it'd be one thing if it was made of metal or something, but the fact that it's
Mm.
non-conductive seems like that heat's going to have a tough time getting to the surface of the blade where it's needed.
It works like the blade material itself works as insulation.
Hmm.
So the heat from the blades, even if there is different kind of technologies yeah, that is leading the hot air, for example, the leading edge, still to have the heat on the surface of the blade, it's not that efficient compared to this surface-based heaters. Some manufacturers are providing a hot air system that is able to work while the turbine is operating, but many of them are de-icing systems, so that typically it works so that when there's icing, the turbines are stopped, and while they are stopped, the hot air is blown inside the blade, and only one blade at once is
Hmm.
melted from the ice. So
Gotcha.
it's not, it doesn't keep the turbines operating all the time, but you need like de-icing time. So
Gotcha.
that is basically the big difference compared to our technology.
Hmm. So there's more like after they're covered in ice, it can help it shed that, but again, kind of slow, one
Mm,
blade at a time, rather than just keeping
yeah,
it off in the first place. Okay. Um, so let's shift
yeah.
to Texas here because I know that's a big point of interest. So from your perspective, following the story a little bit, um, what was your? I mean, how did you feel about just the massive power outages there? And it seems like, yeah, and of course, in hindsight, right? Everyone's a genius in hindsight. Yeah, we should have had these winterized. Well, it's not completely clear whether they should be
Mm,
winterizing for once, twice in a generation storm. But at the same time, if it has the potential to take your whole grid down or the potential to really
mm.
cost you a lot of money, then maybe it does make sense. But what's your perspective on what's happened in Texas?
Of course, yeah, I find it really like sad, and so I feel really sorry about the people in Texas that this kind
Yeah.
of happened. But from if you just talk about from a wind power perspective, until now, maybe everybody has had idea that turbines in Texas don't need like blade heating. But now there was like terrible energy price, like 9,000 US dollars per megawatt hour.
Hmm.
So for average turbine, it is just the payback time for blade heating is just like 1 or 2 days. And if like if we can avoid this kind of outages, so it starts to make sense even in Texas. Made me and many others start to think that okay, it's not that bad idea. It could make sense also there,
Yeah.
and in many other areas as well.
So it sounds like, I mean, really more just like as an insurance policy, because again, yeah, what happened in Texas was tragic. It was
Mm,
awful. Um, and so even if it seems like, yeah, we might not need this, 19 out of 20 years, but that 20th year, like you said, could cost us a ton of money and potentially people's lives, which was awful. And just, I mean, so many people were out of power for multiple days, like
mm,
hunkered down in their homes. Um, yeah, it seems like maybe that insurance policy of having, blade heaters. I know there's some other winterization things that can happen in the nacelle, like different types of oils and stuff like that, to help keep them running in the
mm,
cold, because they do run in the cold, right? There's wind farms all over the world. Like you said, the
yeah.
Lac Alfred wind farm, it runs. Um, and so, yeah, it's I guess it's what they would call a black swan event, and a black swan event is just something that you wouldn't have seen coming, and just has the potential to like topple all of your sort of existing systems, right? Like there's been a bunch. Alan and I talked about on a recent podcast that just like a huge tsunami that like wipes out an island. You like yeah, it's foreseeable that that could happen, being that it's an island, but tsunamis like don't hit very often, right? And so there's this amount of like how much planning should we do, and when does it make financial sense to plan for certain things that are very unlikely but are very potentially disastrous. And this was clearly a disaster here. And just with the way their grid was set up and the PPAs, and like you said, power shooting up to $9,000 per megawatt hour. Like you said, it's the payback time of that becomes very short if that's the alternative. Well, we put blade heating on and the cost associated with it today, versus if this happens and now we're paying $9,000 per megawatt hour for X amount of days, it just like makes financial sense. So yeah,
and this occurred was something like 10 years ago already, or it has. I read that it has happened like once in 10 years in Texas, that it's really cold weather, and was it 2010 when this kind of event also happened. And I've heard some like stories that even that time only this event would have justified the blade heating. Climate change is reality. So what it means that the like normal temperature is not that normal anymore, but we have like a high temperature and a low temperature, and we have this more often this unnormal
just bigger fluctuations,
weather phenomenons. So who knows if it starts to be like every 7 or every 5 years when there's really cold weather in Texas. Or it's like I heard a story of from somewhere in United States that like 2 gigawatts of wind power went down due to icing event in 15 minutes or less than 15 minutes, and this is just too short time, for example, for like coal power plants to start up. So if we would have like at least some of those wind turbines installed with the blade heating, then the effect to the grid would not be that massive and dramatic. Yeah, like you mentioned, it's more could be also thought as insurance for your grid, insurance for your energy supply. Yeah, but the problem is to how to like put the price tag for it. If the grid doesn't require or that you have to produce certain amount of energy, or who would like who would evaluate it, or who should be like responsible for that?
Yeah.
That are like I think maybe those are the questions that will be asked like in the coming weeks, or even now in United States, and maybe everywhere in whole world, as this is widely being everywhere in the news.
Yeah, and unfortunately it does take big events like that sometimes for people like, okay, well, we're going to start, we're developing this new wind project. We need to have a discussion about ice. Like, is it going to be a problem? How much is it going to cost? If it does happen, should we insure against this, with blade heating? Should we, what are the solutions that are going to be right for us on the site? Yeah, I think that's going to be, and like you said, with the bigger turbines reaching higher into the sky, making contact with clouds, all that stuff, it's going to become a bigger problem, not a smaller problem. And like you said, I think that was an interesting point you brought that I hadn't thought of, about just climate change in general, that using the past models of this is how often these kind of storms come through here, you should probably assume that there's, like you said, there's going to be more extreme highs and extreme lows, where, yeah, maybe if it was every 10 years, now we maybe should just think of every 8 or every 7, like you said, because, like we know hurricane season is getting worse. All right. We know lots of things are
Yeah.
changing and we really can't forecast it well, but it probably airs to, if you have a big project like this and you don't want it to go bust, is like, hey, let's just err on the side of caution and say every 7 years we're going to have something like this. So what do those numbers look like? So yeah, maybe that makes sense. So I really appreciate your time today. Is there any place you'd like to, obviously we'll always link in the description. So whether you're watching here on YouTube or listening in iTunes, Stitcher, Spotify, wherever, we'll link to WeissTech so you can follow up with their company, find them on the web, LinkedIn, etc. But Lasse, is there any place you'd like to direct our listeners, ways they can follow up with you, anything like that?
Well, of course, you can find more information from our webpage, weisstech.com, and I welcome everyone to follow us on LinkedIn, and you may send a LinkedIn connection invite to me if you're interested on connecting through this and or asking some more questions.
So yeah, thanks again for being on the show. Really, really appreciate it.
Yeah, thank you very much.
All right, well, that's going to do it for today's episode of the Uptime Podcast. Thank you so much for listening. Be sure to subscribe, share the show with a friend, and be sure to check out the description links, whether you're on a podcast platform or you're watching on YouTube, where you can find links to follow up with Lasse on LinkedIn, follow up with the company WeissTech on their website, their YouTube channel, or LinkedIn as well, and follow up with WeatherGuard Lightning Tech, the sponsor of this show, through the links in the show notes or the description. Thanks again for watching, and we'll see you next week on the Uptime Podcast. Is downtime causing you financial pain and putting a stop to your power production for months on end? It's no secret, lightning strike damage is a major cause of wind turbine downtime. This damage is preventable with our easy-to-install strike tape lightning protection system for wind turbine blades. Our incredible engineering, build quality, materials, and edge sealants withstand up to 5 times more abuse in the toughest weather and lightning conditions. And we've got the research to prove it. If you're tired of constant downtime, we can help. Reach out to us at weatherguardwind.com and schedule a free call. We'll get your uptime back in no time.